everybody, welcome back. Today we are talking about something a little bit more complicated than our normal number patterns. Yesterday we talked about number patterns and how they can either be increasing or decreasing. Today we're doing the exact same thing, but it's going to be in the form of input and output tables. Now this is something completely new, so don't be afraid when you hear the words input and output, okay? Because really the words mean in and out. So it's like I want you to picture a machine. It's like we're putting a certain number into the machine and something is happening to it in the machine and it comes out as a separate number, a different number. Our job is to figure out what is happening to it inside of that machine. How is it turning from this number to that number? We're figuring out the rule, and then we're going to figure out the missing parts of the table. So input output table, basically it's what you put into the table. It comes out as another number based on the rule. And the rule here is how the number changes inside of it. So it can either increase or decrease. If we look at this table right here, and it's not an actual table with legs, it's a math table, okay? It's just a word for all these little boxes. That's our table. It's going in as one number and coming out as another number. So we see here the number's going in as a 6 and it's coming out as a 10. So that number got bigger. Our two options when a number gets bigger are either we added to it or we multiplied to it to make it bigger. So we have to decide, is this going to be an adding or a multiplication rule? Next, let's look at another example. We have a 4 going in as a 4 and coming out as an 8. So let's figure out what the rule is here. Let's try adding first. We always want to try the easiest one first, and adding is much easier than multiplying. So let's see if there's an adding rule here. It's going in as a 6, coming out as a 10. Let's see how much it takes to get from 6 to 10. If I put 6 in my head and count up to 10, 6, 7, 8, 9, 10. So that was plus 4. So I'm going to see if that same rule works for the next set of numbers that we have here. Does 4 plus 4 equal 8? Count up 4 more, then that gives me 4, 5, 6, 7, 8. So that rule is working for both of these. So what's happening here with this line is like we're doing 6 plus 4 equals 10. 4 plus 4 comes out as an 8. 7 plus 4, what's it going to come out as? 7, 8, 9, 10, 11. And that's going to help us fill in the missing parts of our table, okay? Next, we have a different table, and we are going to look at the numbers going in and coming out. The difference here is that the number is going in as a 14 and coming out as an 8. The numbers here are decreasing, so that means that they're getting smaller, meaning that it's going to be either a subtraction or division rule. Now, subtracting is much easier than dividing, so we're always going to want to try and see if we can subtract first to see if that will work. So 14 minus what equals 8? There are two ways you can solve it. You can either put 14 minus 8 to get the difference, or you can put 8 in your head and count up to 14 to find the difference. I always like to count up because it's easier for me to do that than counting backwards. So 8, 9, 10, 11, 12, 13, 14. We stop when we get to 14. The difference is 6. It took us 6 to get from 8 to 14. So it is minus 6. Let's see if that rule still works for down here. You need to check it on all of them to make sure that the rule works for both sets of numbers. 25, take away 6. Let's see. If I do 25 minus 6, does that equal 19? Well, we can either put 19 in our heads and count up to 25, or we can count backwards from 25 to 19, or you can write it out to the side and do 25 minus 19. Whichever way you prefer, whatever works for you, that's fine with me. I'm going to put 19 in my head and count up to 25. 19, 20, 21, 22, 23, 24, 25. That is 6. So our rule is working. It's both negatives. It's both minus 6 for both of these. 14 minus 6 and 25 minus 6. So here we have 12. And if we do the same rule, 12 minus 6, what's that going to come out as? Well, 12 minus 6 is, if you said 6, you are correct. The rule is minus 6, and our answer is also 6, okay? So let's look at this. We have an in and out table, an input-output table, however you want to call it, and we have a few more numbers added in this time to make it a little bit more interesting. So it's going in as 21, coming out as 24. we have one going in as 13, coming out as 16. You always want to look at your two examples or however many examples you have to figure out the rule, okay? Now, I noticed that they're going up by just a little bit. They're not going up by like huge amounts. So that's probably going to be an adding rule. So we always want to start out with an adding or subtracting rule, just trying to figure out which way. Since it's getting bigger, that means that I'm adding to it. So we're going to try an adding rule and see if that works. So let's see how many it takes to get from 21 to 24. 21, 22, 23, 24. It took me plus 3 to get from 21 to 24. Let's see if the rule plus 3 works for 13 to get to 16. 13, 14, 15, 16. It worked. So our rule here is plus 3. Now, I want to find out what 5 plus 3 is going to come out as. So it's going in as a 5, and it's going to come out as a what? The rule is happening to it while it's in there, and it's going to come out as an 5 plus 3, 5, 6, 7, 8. It's going to come out as an 8. Next, we have 18. It's going in as an 18. The rule is happening to it while it's in the machine, and it's going to come out as a what? 18, 19, 20, 21. It's going to come out as a 21 because all of these are getting plus 3 added to them, okay? So I like to imagine this line as when the rule is happening to them because it's going in as a certain number and coming out as another number. So it kind of like, it's like transforming them like a wave, like woo, like transforming them into a new number. We just have to figure out what's happening to them when it's transforming them, okay? Let's talk about another one. Here it's getting what? Bigger or smaller? They're going in as a 10, coming out as a 20. Going in as a 4, coming out as an 8. What's happening? Is it getting bigger or is it getting smaller? They're getting bigger. So it's going in as a 10 and coming out as a 20. Let's figure out if our rule is an adding rule or a times rule. So first of all, to get from 10 to 20, let's figure out how we did that with addition. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So plus 10. 10 plus 10 gave us 20. So let's see if that worked for 4 and 8. So if I do 4 plus 10, that's going to give me 14. That's not what this number is. So it doesn't look like our adding rule is going to work. If the adding rule doesn't work, then our only other option to get bigger is multiplication. So now let's figure out what times 10 equals 20. How many 10s does it take to get to 20? Well, 10, 20. It took 2 10s. So 10 times 2. Our rule here is going to be times 2. Let's see if that worked for 4 times 2. 2 4s, 4 and 4 gives us 8. So that is correct. So let's figure out what 3 times 2 is going to be. You can either draw circles, 3 circles, and put 2 in each group to get your answer, or you can skip count by 2s. I like to skip count by 2s because it's a lot easier that way. So let's skip count by 2 3 times. 3 times 2. 2, 4, 6. Same thing for 8. We're going to do 8 times 2 to see what that comes out as. 2, 4, 6, 8, 10, 12, 14, 16. So it's going to come out as a 16. Awesome job, guys. All right, let's try another one. Okay, this one is going in as an 11 and coming out as a 13. So we're getting bigger, so we know it's going to be either adding or multiplying. Down here, we're looking at 18, and it's coming out as 20. So let's figure out how many it takes to get from 11 to 13. 11, 12, 13, plus 2. Let's see if that works for 18 to 20. 18, 19, 20. Yes, it does. So our rule is plus 2 here. The reason why I want to show you this one is because I want you to look at your table and see if you notice something different about this one. Up until now, you have had all the n numbers filled in for you. Okay? So here, we were figuring out, we have the out number, but we got to figure out the in number, okay? Before we do that one, let's think down here. 4 plus 2, it's going to come out as a 4, 5, 6. It's going to come out as a 6 down here. Now, if we have the out, we're basically sending this number backwards through the machine, meaning we have to do the backwards rule to it. So instead of it being plus 2, we're sending it backwards through the machine. It's going to actually have to be minus 2 for it to work because we already have the answer. We already have the out number. I'm trying to figure out how did I get from 2 to 7, okay? So 7, instead of 7 plus 2, we're going to do 7 minus 2 because we're sending the 7 backwards through the machine. 7 take away 2, 7 take away 2 is 5. Because it is going through the machine as a 5, and then plus 2, it would come out as a 7. We had to do it backwards to figure out what it was before that, okay? I know it's a little bit weird, but just stick with me. I promise it'll get easier, okay? So here we have an in-out table. We have an in missing, and we have an out missing. That's fine. We are going to look at the two finished ones that we have both the numbers for to find the rule. First of all, the rule is getting bigger or smaller. It's going in as a 12, coming out as a 7. It's getting smaller. So that means we're either going to be subtracting or dividing. We always want to start with subtraction to see if that can work first. So I'm going to try to figure out the difference between 7 and 12. I'm going to put the small number in my head and count up to 12 to find the difference. How much does it take me to get from 7 to 12? So here we go. 7, 8, 9, 10, 11, 12. It took me 5. So 12 minus 5 gave me 7. Let's see if that's true for 13 minus 5 equals 8. If I put 8 in my head and count up to 13, 8, 9, 10, 11, 12, 13. That's also 5. So minus 5 is our rule. And we can you can pick where you want to start on the chart. If you want to start with the easy one, where you have the in number and you're figuring out the out. 17 minus 5 equals, see if you can figure that out on your own, equals 12. Very good. Yes, 17 minus 5 equals 12. So now we're going to have to do, we have the out, and we have minus 5 as the rule here. But since we're going backwards through the machine, we're trying to find the in. Whenever you're finding the in, you have to do the rule backwards. So we're going to do 5, not minus 5, but 5 plus 5. So 5 plus 5 is 5 plus 5 is 10. So it went in as a 10 and came out as a 5 because the rule minus 5 happened to the 10, but we didn't have this information. We are trying to fill in the missing information, and if the missing information is the in, then you have to do the rule backwards to find it, okay? If your missing information is the out, you just do the normal rule because it's going through the machine like normal. But if you're missing the in and you have the out, you're going backwards through the machine, which means you have to do the rule backwards. And the rule backwards of minus 5 would be plus 5, so that's how I got 10. And as you get more experience with this and as you use this more and more, it will become easier and easier. It's a little tricky starting out, but don't get discouraged. It's not as hard as you think it is. Just slow down, use your brain, use common sense to help you figure out these problems. If you guys need any help at all, please feel free to reach out. I'd be more than happy to help. Good luck, guys.